Today we are going to discuss technical change or technical progress. And in this lecture, we are going to deal with different types of technological changes. Basically, our purpose is to look at Hickesian neutrality and Harrod's neutrality relating to technical change. Technical change means what? Technical change means technical progress, invention, innovation, diffusion of technology. It is a process which is taking place continuously, and technology is improving. As a result, not only technology is improving, technology is being diffused throughout the country. Now, technical change occurs due to research and development. The growth of any economy, technical change plays a very important role. Developing countries are called developing countries, or for that matter less developed countries, because of the fact that GDP per capita in these countries is lower than the GDP per capita in developed countries. One of the important reasons for this is the use of obsolete technology or backward technology in these countries. In these countries, what we find, we have plenty of natural resources, yet these resources are not utilized up to their potential because of lack of technology. Technology is an important determinant of growth. Over a period of time, as technology is changing, in most of the cases, technology gets embodied in capital. New capital becomes available and productive capacity of the country goes on increasing. Theoretically, when we are talking about technological change, what it means is that there is a shift in the production function and the change in the slope of the production function. Or in terms of isoquants, one can say that technical change leads to shifting of the isoquants towards the origin and also sometimes the change in the slope of the isoquants. In the growth models, what we find, some of the growth models treat technological change as exogenous, whereas some of the growth models treats technical change as endogenous. As far as we are concerned, we are not going to discuss the growth models. Today, our purpose is to discuss different types of technological change. The technical change can be labor saving, capital saving, or neutral. Regarding these concepts of technical change or technological change, we shall be discussing two varieties of technological change. One we call as Hicks neutral and the other we call as Harrod neutral. These are the versions of technological changes which have been given by Hicks and Harrod. First, we will be discussing Hicks neutral technological change. A technical change is said to be Hicks neutral technical progress when the ratio between the marginal product of capital to that of labor remains unchanged as a constant capital labor ratio. What it means is that when technical change is taking place, the ratio of marginal productivity of capital and labor remains unchanged, and at a technical change is said to be Hicks neutral technical change when the ratio between the marginal product of capital and that of labor remains unchanged at a constant capital labor ratio. What constant capital labor ratio means, or for that matter, capital labor ratio means the quantity of capital utilized divided by quantity of labor. What we are saying that when the ratio of marginal productivity is constant, then this ratio is also constant in spite of technical progress. We shall be discussing it in terms of production function. Consider the following production function. Equation 1, where we write y is equal to AT into function of K and L, where Y is the output, AT stands for technical progress, and K stands for capital, L stands for labor. On transforming this production function, we can write Y is equal to A within bracket T function of small k, where small k is capital labor ratio, and small y, or the dependent variable, is where small y is the per capita output or output per labor, and small k is the, in order to explain the Hicks neutrality, we are going to use a particular diagram which is shown here. In the diagram, on the horizontal axis, we have the capital labor ratio. On the vertical axis, we have output per capita, or in other words, output produced by per unit of labor. Now there are two production functions which are shown in the diagram. One production function is OP, the other production function is OP1. These production functions show as capital labor ratio is increasing, output per labor is also increasing. But looking at the shape of the production functions, what you find that output per unit of labor is increasing at a decreasing rate. This is the reason why the diagram is, or the production function is concave downwards. The technical change will be said to be Hicks neutral when production function OP shifts to the new production function OP1 and causes an increment in output equal to AP without any change in factor production proportions. What it means is that factor proportion, capital labor ratio remains constant. In other words, a technical change that does not cause the ratio of marginal product of labor to that of capital to change at constant capital labor ratio is said to be Hicks neutral. This argument is highlighted by the segment OM in the diagram. It indicates that the ratio between marginal product of labor and marginal product of capital remains unchanged. To prove that OM is the ratio between marginal product of labor and capital, consider the triangle OWM. Since WM is the slope of the production function, which technically is the marginal product of capital. This is marginal product of capital. Why it is marginal product of capital? Because on the horizontal axis, we have capital labor ratio and on the vertical axis, output per man. So, when there is any change in the capital labor ratio, as a result, there is change in output per unit of labor. If we take the first and divide it by the second, what we get is the marginal product of capital. That with the increase in capital labor ratio, how much output per unit of labor is increasing. This is the marginal product of labor. Therefore, the slope of production function OP can be written as theta OW upon OM, which implies OM is equal to OW upon theta, where theta is the marginal product of capital. Now, hence OM is the ratio between marginal product of labor to that of capital. In the diagram, OM is the ratio between marginal product of labor to that of capital. In the graph, Hicks neutral technical progress requires that when technical progress shifts the production function from OP to OP1, the ratio of marginal product on respective production functions should remain constant. In the graph, Hicks neutral technical progress requires that when technical progress shifts the production function from OP to OP1, the ratio of marginal product on respective production functions must be same on any vertical line drawn from x-axis like KB in the above graph. Again, it is also required that the tangent MB on the production function must originate from M to the left of O, like tangent before the technical change. In the graph, both tangents MA and MB are originating from M, and thus proving that the point that the ratio of marginal product of labor and capital are equal on both the graphs. Since both the tangents are originating from point M, when we are drawing a tangent at point A and B, what it means is that on both the graphs, the length OM is same, which implies that ratio of marginal product of labor and capital is constant on both the production functions. Hence, we conclude that Hicks neutral technical progress cause output per unit of labor to increase by AB, but the factor proportions remain unchanged at OK. It is also observed that under Hicks neutral technical progress, the factor shares remain constant when factor proportions and relative remuneration of labor and capital are constant. It also occurs when the elasticity of substitution between labor and capital is equal to unity. Accordingly, in terms of the above graph, it implies that when the slope of production function OP1 at point B is greater than the slope of the production function OP at point A is in same proportion as output KB greater than KA, then technical progress is said to be Hicks neutral. Now, there is some criticism of Hicks neutral technical change. The definition is rigid, even when there are large number of factors of production involved in the process. Since Hicks neutrality depends on elasticity of demand and elasticity of factor substitution, it becomes very difficult to analyze the neutrality with these tools. Hicks neutrality is applicable in the frame of static economic analysis. Basically, what it means, static economic analysis, that we are comparing 2 points. Once production is taking place at one point, second, when the production function has shifted, the production is taking place at another point. And on that basis, we are coming to the conclusion that technical progress is neutral. The model of technical change is further extended by Hicks under biased technical change. The biased technical changes can be labor saving technical change and capital saving technical change. Now, in the case of, if we use the isoquants, in the case of biased technical change, what actually happens is that if we draw a line cutting across various isoquants through the origin, at the points of intersection, the slope of the tangent is changing or different at different isoquants, which means that technical progress is not neutral. If the slope of the points of intersection are same across the isoquants, then we can see that technical progress is neutral. Labor saving technical change. A technical change is said to be labor saving technical change if it increases the marginal productivity of capital relative to that of labor at a constant capital output ratio. Capital saving technical change. A technical change is said to be capital saving technical change if it increases the marginal productivity of labor relative to that of capital at constant capital output ratio. Having discussed Hicks neutral technical change, we now discuss Harrod neutral technical change. The definition of neutral technical change was given by Harrod in his paper Towards a Dynamic Economics. According to Harrod, technical progress is neutral when at a constant rate of profit, the capital output ratio remains constant. Harrod has used the word constant rate of profit, whereas later economists changed it to constant rate of interest. We shall be talking only about constant rate of profit. If after there are certain points which we would like to mention before discussing in detail the technical change which Harrod calls as neutral. If after technical change the rate of profit remains constant but capital output ratio increases, then the technical change is labor saving. On the other hand, if after technical change the rate of profit remains constant but capital rate of profit remains constant but capital output ratio falls, then the technical change is said to be capital saving. Harrod's definition of neutral technical change is superior to Hicks' definition of neutral technical change in the sense that it is applicable to dynamic economic framework rather than just a static situation. In order to explain Harrod's neutrality, we introduce the production function. The production function is Y is a function of capital and effective labor. We write effective labor as A within bracket T times L. In this production function, Y is the output, K is capital, and A within bracket T times L is the effective labor force. The neutrality will be exhibited in the function when there is constant returns to scale and a proportional rise in capital and effective labor. Harrod's neutrality in technical progress is explained with the help of the diagram. In the graph, capital per labor is represented on x-axis. Our capital labor ratio is represented on x-axis, and output per labor is represented on y-axis. The curve OP is the initial production function, and the curve OP1 is the production function after technical change. The capital output ratio on the respective production functions in the figure is OK1 divided by OY1 on production function shown by curve OP, and on the curve OP2 the capital output ratio is OK2 divided by OY2, and these ratios are represented by point A on curve OP and point B on curve OP1 as the line segment OR originating through the origin and passing through point A and B. The capital labor ratio remains unchanged. That means OK1 upon OY1 is equal to OK2 upon OY2. In Harrod's model of technical change, it is required that the rate of profit should remain constant along the constant capital output ratio after technical change. It means that marginal productivity of capital or rate of profit at point A and B must be equal. The equality of the marginal productivity in turns requires that slope of production function OP must be equal to slope of production function OP1 at points A and B. Harrod's neutrality is proved when the tangent at A and tangent at B are parallel to each other. In the graph, it can be observed that tangent TG at point A and tangent T1G1 at point B are parallel. Thus, Harrod's neutral technical change that causes the production function to shift to OP1 depicts the equality of capital output ratio at A and B as represented by the ray OR passing through them, and also the equality of the slopes of the tangent at A and B, thereby showing a constant rate of profit. John Robinson and other economists have shown that technical progress in Harrod's neutral as well as Hicks neutral will be same when the elasticity of substitution between the factors of production is unity and income share among the factors does not change. The concept of technical change has been criticized. The theory of technical change is based on perfectly competitive market, which is unrealistic in reality and hence fails to consider factor market and product market imperfections. According to Solow, machines depreciates exponentially, but Stiglitz contradicts him and indicates that it may be reasonable assumption for telephone poles, but it is not the case for machines. Third, the technical model does not take into account the effect of expected wage on machine construction. An investor takes into account the expectations of wage extending to future before constructing a machine. In that case, the real wage rate will not be equal to marginal productivity of labor on the machine of a given vintage and type, but it will equal the average output per worker on the least efficient machine. The entire model is based on the hypothesis that machines are of different types and new machines are better than old ones. The assumption on which the model is based is related to fixed labor requirement. This is an unrealistic for any economy with higher output per worker, which may have lower capital labor ratio. It concentrates only on technical progress embodied in new machines and ignores the fact that over a period of time, innovations are taking place which makes labor more effective, and the technical progress does not depend only on machines, but it also depends upon the labor.